let's clean the table and let's start the lesson. Please clean the table first. You can still see some like mathematics worksheets or like geography worksheets there. Maybe we don't need calculator. Thank you. Okay. So by the end of the lesson, you are able to learn about 5 things, which is the knowledge, skills, and values and attitudes. The first one is recognizing the different forms of energy to be converted from one to another, and also recognizing some common energy conversion process. Also, we would have a demonstration later on, and you need to get the result of the experiments. Then you would need to apply the concept of the energy conversion by discussing with the classmates. And finally, you would realize that actually energy conversion is everywhere around us. So here's the table of contents. You can see that first of all, we would do the revision, which is the checking the post-lesson task and also the pre-lesson task that I just reviewed to you yesterday. And the second thing is introduce the energy conversion, which is the lecture part. And also then we would go to the laboratory in the 5th floor and do the demonstration. And we would do 3 demonstrations today, which is the fruit clock and also the metal spiral and magnesium ribbon. And 4th, we're going to apply it to the daily life. Then we will do a conclusion and assessments. Is anybody clear about that? Understand? Okay. So first, the revision part. Please take out your pre-lesson task and post-lesson task. Okay. Test. So, for the first question, you can see there's a source and form of energy, right? For the first source, it is given out when an object vibrates. Apart from the guitar vibrates, do you remember that last time I showed you another thing which can also vibrate, and I'm vibrating it now, at this moment. Yes, the organ which lets you to be able to talk or speak, right? It's the vocal cord. In Cantonese, sing dai, right? So, can I invite number 34 to answer me this question?
Sound energy.
Yes, sound energy, very good. And 34 again, can I ask you one more question? If you need to choose a keyword from the whole sentence of the source of energy, which one would you choose? Choose one keyword.
Vibrates.
Sorry?
Vibrates.
Vibrates, yes. This is another form of energy. We will talk about it later. Yes, but it's not the name of the energy form. It's something else. If you're totally correct. Okay, so for the second one, it's stored inside the food and the batteries. Can I invite number 10? Yes? Sorry? Yes, correct. Thank you. So it's chemical energy. You may copy it down, or you can use a red pen to take it. So actually, apart from food and batteries, can you give me one more example that exists? Volunteer, you can raise up your hand. Yes? Charcoal, right? You mean the charcoal that we usually use for barbecue? Yes, charcoal. Actually, there's also chemical energy in the charcoal. So not only in the food or battery, but also charcoals, which is some fuel for the combustion or burning, let's say. Okay, for the third one, it enables us to see the things. Can I invite, yes?
Light energy.
Yes, light energy. And if I have to choose a word which is the key word for the source of energy, which one would you choose? Or which two? One or two is acceptable. Which one or two? From this sentence, light enable us to see things?
Enable and see.
Yes, correct. So even you're in a very dim area, for example, when there is, let's say, in the night, like there's a sudden stop of the electricity and then the light all goes off, is there still light energy? No? Yeah, no, raise up your hand. Yes, raise up your hand. Why it's yes?
Because if there is no light, if there is no light, then we can't see anything. But if the light off, but if the lamps all goes off, we can still see.
Why the lamps goes all off then, but then we can all still see it?
Maybe because of the moonlight.
Yes, there's still light, but it's from the moonlight. And do you know where the source of the moonlight? Yes?
Reflect from the sun.
Yes, that's correct. So even though it's at night and then there's no lamp, all the lamps goes off, there's still some light energy from the sun. Yes, that's correct. And number 4, can anybody tell me the answer? Yes?
Thermal energy.
Thermal energy. Can I ask you one more question? That is, can I say heat energy? No, why? Or maybe you can tell the difference between heat and thermal. Yes, that's correct. Because heat is just the flow of the thermal energy. So when you say heat energy, it's partly correct, but not very accurate. So next time, remember to write thermal energy instead of heat energy. Is that okay? So, may I invite number 28? Can you answer me throughout this whole sentence, which one is the most important? Higher temperature, yes. And if you have a highlighter, you may also highlight the temperature. Actually, everything with temperature has the thermal energy. Even like the Coca-Cola in the fridge, it has thermal energy because it has temperature. Even though it's very low, it still have temperature. Is that okay? Okay. And for the 6th one, maybe can I invite 25 to answer me the question? What form of energy is it shown in the paper? Yes, kinetic energy. And it states that all moving objects have the kinetic energy, and it relates to the speed and the mass of the object, and what the object moves, then the more kinetic energy it is. Do you still remember I invite one of your classmates to throw the tissue? Yes? Yes, it's you, right? Yes? So the object move?
Faster.
Yes, the faster. And the second question is, the second answer is? Sorry? Greater? Yes, the greater the mass. That's very good. So it means that you really pay attention in your English lesson, because maybe some of the classmates would answer me higher or heavier. Yes, but actually heavier is correct if there is no the word of mass, right? Here it says what's the mass? You won't say the heavier the mass. You would say the greater the mass, or the larger the mass, or even the bigger the mass. But you won't say the heavier the mass. So it's an English problem, okay? And second last, what is this? Yes? Potential energy. Thank you. Number 17. Can you repeat her answer? 17? Yes, very good. Potential energy. And all the object would gain the potential energy when it's raised to a yes.
Higher position.
Yes, thank you. Then, if I said like, if yes. Sorry. Highest, but here it says so you want to write highest, right? What if here is the highest and here is less high, but it's still higher? Let's say comparing to the ground, it's still higher than the ground, right? But it's not the highest. Here is the highest. And if I put this here, would it gain the potential energy? Yes. Yes, it's actually yes. Because it's still higher than the ground, right? So it's actually the comparison of the position now and then. If the position now is here and then it's here, then the potential energy it gains is from here to here. Is that okay? If it's originally on the ground, like on the ground here, and if I put it here, then the potential energy gain is from the ground to here. Is that okay? So it's actually the comparison between now and then. So there's no highest. You can just say higher. Okay? And the higher position, the what potential energy it has? Raise up your hand, yes? More, yes. Thank you. And you can see that actually there are two kinds of different potential energy. What are they? How about the first one on the left-hand side, the elevator? What kind of potential energy is it? It has a very special name. Raise up your hand if you know the answer. Or I would pick. Yes? Yes, gravitational. Sorry for the mic, it's a little bit broken. Gravitational potential energy. Yes. So no matter you're going up from the stairs or by the elevator, you would get the same amount of potential energy, right? Because if it's the same from the ground floor to the fifth floor, or going by the elevator from the ground floor to the fifth floor, your position difference is the same. So you would get the same amount of energy, potential energy. And lastly, if some object can be stored the potential energy when it's being stretched or compressed, it has the potential energy as well. So it's like this. You see? What I am doing now Yes. And what kind of energy I'm storing inside? Yes. And what if I do this? Then
Kinetic energy.
Potential conversion to
yes, actually you say the keywords of our lesson today. And
how about
the last one. What is the last one?
electrical?
Yes.
The electronic energy.
Electronical energy. Yes. Wait. A little bit wrong. Not electronical energy. It's like the spelling is a little bit inaccurate. It's not wrong, but inaccurate. Yes.
Electrical.
Yes, electrical. So it's about the English thing. Can you repeat his answer? Yes, electrical. Thank you. So the electrical energy actually, like the sky, the nature has already demonstrated it when we are starting the lesson. Is that okay? And so for this part, last time we don't have time to go through it, but I told you to study it at home. And can we go through it quickly? Let's say number 20. Can you answer me the whole first question? This whole one.
Yes.
In full sentence. Thank you.
We can measure energy in joule.
Yes.
Or kilojoule for a larger amount of energy.
Yes. Wait. It's too sensitive. Or kilojoule. Remember that when you're doing the exam, actually you need to spell it. And may I invite number 27? Number 27? Can you answer me the second question here?
We can also use calorie or kilocalorie to measure the energy running out.
Or kilocalorie, yes. So remember, when it's kilocalorie, then you need to add an X because it's kilocalories, right? So it's CAL and KCAL. Sorry for my ugly words. I hope that you can understand. If you don't, then you can tell me, then I can write it again. So everybody follow here? Okay. Then the next part, which is the last part of this. Energy conversion. So energy can actually be converted from one to another, and it's called, you can, okay?
Energy conversion.
Yes, it's actually the same title as this pre-lesson task. And there's an example. The first example is the hairdryer. Can you tell me from what form of energy it's converted from? Yes? Yes, electrical. And converted to, yes? Kinetic energy? Yes. Actually, it's kinetic energy of, can you further answer me? Kinetic energy of, it's extra, but yes. Of the wind form? Wind flow, yes. So actually, it's kinetic energy of air to form the wind. Okay? And also, thermal energy, yes, because you will feel hot. And also, sound energy, thank you. And the example 3, it's the burning candle. What kind energy is stored in the candle?
Chemical energy.
Yes, chemical energy. Like what this student said, charcoal, which is the energy source of the combustion, is the stored chemical energy inside. So SO on the wax also does. And chemical energy stored in the candle converts to,
Light energy.
yes, to enable you to see, right? And thermal energy, yes. Very good. So do you need more time to copy it down? No? So everybody follow this, right? Okay, good. So let's go back to here. So after knowing all these kind of energy forms, yes? Oh, sorry, I missed one. So here's the last one, the simple catapult. What kind of energy is stored in the rubber band here? Here?
Potential energy.
Yes, potential energy. And it's converted to the last one. Sorry? Yes, thank you. Okay. So after we know all these kind of different forms of energy, then do you think that the form of energy would always stay the same? I will answer this question later. But by the end of the lesson, I want you to answer these two questions. That is, what is energy conversion and how can it be applied to our daily life? So here we now finally come to the introduction of energy conversion. So if I have to answer this, I would say, no, actually energy can be converted from one form into another, which is called energy conversion. If somebody doesn't know what this conversion means, this is the dictionary, and in Cantonese it's 改變 or 轉變 or 轉化. Is that okay? So if conversion means change, then actually when it applied to the energy case, when it's energy conversion, then it is energy can be converted from one form into another, right? So can you guys read aloud once, energy conversion?
Energy conversion.
Thank you. For example, this one, what kind of energy is it from? Yes?
Electrical energy.
Yes? And it's converted to thermal energy. Yes? That's why the toast can be heated up, right? And for the second sample, oh wait, it's actually the same as the pre-lesson task. And can somebody answer me this question? Yes?
Chemical energy.
Yes? Maybe the full sentence this time because we have already gone through it.
Burning candle. The chemical energy is stored in the candle.
Mhm.
And it turns into light energy and thermal energy.
Yes, very good. And maybe can his neighbor help me to repeat the whole sentence once? Later on, I will point out one mistake you two both made, but later on, I will tell you later. So this one is that plant carrying out the photosynthesis. You know that plants, how plants carry photosynthesis? It has to have the sunlight, right? And then it will produce the fruit. So what kind of energy conversion is it? Yes? Sorry? Yes, light energy convert to chemical energy. Yes. And what does this circle mean? I want you two to answer me. Due to I can hear the answer. Yes?
Convert.
Yes, convert. It's the arrow actually means energy conversion. Okay? So it actually should be the light energy from the sun is converted to chemical energy. Right? So can you two repeat the full sentence this time? Yes, thank you. I can hear the verb change from transform or change to convert because convert is the most accurate verb. Okay? And third, we will have the demonstration. Now take your textbook, one pen and pencil, no iPad, and line up outside. We'll go to the laboratory. No, I mean me, myself. Yes? Not exactly, because the experiment that we're going to do today is not very dangerous. Flush your hands. It's actually tying my hair because I still need to tie my hair, or else if my hair touches the fire, then my hair will be on fire. It's okay. Let's wait for a second. I need to project it. Okay. So later on, we will do some procedures. That is, first write down your guess with the pencil on the textbook page. Actually, 90 to 91, not 98, not 89 to 91, because their main focus is 5, 7, and 8, which is the block, and also the metal spiral and the magnesium root. Okay? Then we would observe the demonstration one by one. Then we would discuss and draw conclusion every time when it's over. Then we would correct the answer with a pen. Clear? So, 4 steps. Write down the guess first, then observe, then discuss and draw the conclusion. Finally, correct the answer with a pen. So now, you would have 3 minutes to do the guess. Once again, our main focus today is 5, 7, and 8. to do the demonstration? Yes? I can see you. So, can you all tell me which demonstration we're doing now? Number 5 or 7 or 8? Can you show me with your fingers? 5, yes. And our experiment is a little bit different from the textbook. According to the textbook, the experiment is actually like light up the LED lights with what? With the lemon cell, right? And now we're doing a fruit clock with lemon cell. So it's still light up, but not lighting up the LED lights, but lighting up the clock. You can see that, look at the screen. There's nothing on it, right? Can you help me to hold it? And then ensure everybody can see the screen. You can check here if anybody can see the board on the screen. Okay? So here, if I connect this metal to the lemon cell, what would happen? Then there will be electricity flowing, right? So then there will be, yes? And the lemon is chemical energy, right? There's chemical energy inside the lemon. And when I connect to it, see what's happening? What's happening? Is everybody on screen? Yes? What's happening? Louder? Shh. I can't hear you. Yes, there's electrical energy, but what is the final form of energy? You can see. Yes? You're too shy? Okay. Okay. Is that light energy? Okay. Thank you, student Albert. Okay. So later on, I will show you a game. After 1 minute, then this clock would turn to 12:01. Yes. Later on, I will show you. Or maybe 12:02. Let's see what time do we need. Okay, so for this experiment, we can see that what kind of energy is converted to what kind of energy. Yes? Repeat because it's too loud. Yes. And may I invite number 14 to answer the question again? Can you repeat what your classmate has mentioned? Yes? I mean that what kind of energy conversion is it in the experiment of fruit clock? And your classmate just answered the question. Can you repeat the answer in full sentence? I can't hear her. Can we listen to our classmates? Okay, can you repeat? About the lemon cell. Yes? I can't hear you. Number 2. Yes, thank you. So, for the next one, which one we're gonna do? Number 5 or 7 or 8? Can you show it by your fingers? 5 or yes? Here, do you know which one I'm doing the next? What is this?
7. No, there's 2 fingers, but it means 7. Okay? Okay, for this experiment, can the student behind and also the student there to help me to close the window first? Do you know why? Can you close the window first? You know why? Can you help me to close the window? Yes, thank you. And then you can go back to your seat. Thank you for my student helper. Okay, so what is your guess of this demonstration? What is your guess? What have you written down for? Sorry? What energy would be converted to what energy? For this experiment. What thermal energy is it? Sorry, what kind of energy form is it providing? Yes, thermal energy. Raise up your hand first. Yes? Convert to thermal energy, yes. Convert to is the thermal energy from the Bunsen burner convert to the kinetic energy from this metal spiral. Okay? So now you can see careful. Now is the demonstration time. I will do it once only. If you missed it, then I won't do it again. Okay? In what way? Up and down, left and right, or what is it? Round, right? What does it mean by round? It's actually spinning. You know the word spinning? 旋转 in Cantonese. Spinning. So, can number 22? Number 22? Oh, sorry. Then 21. 21. Can you repeat or can you tell me what is the energy conversion of this demonstration? If you want to answer, raise up your hand. Number 21. Can you sit down, please? Sorry? Chemical to kinetic. Actually, you're right. But there's something in between. What is it? Yes, it's chemical because you know that what's inside of this is town gas, right? Okay, town gas. And the town gas is actually the chemical energy. And when we're burning the chemical energy inside of the town gas, then it would have thermal energy, yes? And the thermal energy heat up the what? Actually, it's heating up the air. So the air would gain the kinetic energy. After the air gets the kinetic energy, what would it convert to? It's the kinetic energy of, what is this? Metal spiral. Yes. So actually, on the boat, there are just 2 steps, right? 2 steps. But in the reality, you know that how many steps are there? 3? Which 3? Yes, the kinetic energy of air. So there's 4 steps. Chemical energy of town gas convert to thermal energy, convert to kinetic energy of air, convert to kinetic energy of yes, that's correct. Anybody doesn't know this answer or haven't copied it down? I can repeat it once. Or I can tell somebody else to repeat it as well. Okay. So the last experiment, which experiment are we going to do? 1, 2, 3, 4, 5, 6, 7, 8. 8. Show me with your finger. You want to try 8, but you have the student helper already. Okay? Who wants to be the student helper this time? You also need to light up the... Okay. Then this time we don't need a standing clap. This is the magnesium, right? You can see magnesium. And do you remember this symbol? Flammable. Yes. And it's not simply flammable. For example, actually, paper is also flammable, right? But what is the difference between this flammable and this flammable? It's even more flammable, right? Oh, I forgot one thing. Can you help me to close the door? No wonder when I was doing the Bunsen burner test, can you observe the flame is actually like this way? Do you remember? It's because I forgot to close the door. Now it should be okay. And does anybody know what is welding? English time. What does welding mean? In Cantonese, it is 燒焊. You know 燒焊? Yes. Those like workers would end up with what? Mask. Listen, it's very important because later on you may get hurt if you don't listen to it. So in welding, 燒焊, those workers would wear the mask, right? It's because the light that the magnesium ribbon can emit, not just the visible light, and also invisible light, which is UV light. Do you know what is UV light? Raise your hand if you yes. Yes, ultraviolet light. What is it in Cantonese? Yes, 紫外線. It would hurt your eyes. So later on, when I'm doing the experiment, what do you need to do? Look at it. No. Look at it directly. No. Then what do you need to do? Yes. Look at the screen, or you can look at this iPad. Like look at here. Then actually you can see a little bit of here, right? Even though I'm looking at here, I can still see this block, right? Right? So, later on, look at it indirectly. So, what is the guess? What is the guess? What? Oh. Thank you for reminding. What is the energy conversion? I know that the nature is very fantastic, but my lesson is even more fantastic, okay? Yes? What is the energy conversion? To I'll wait until everybody is watching. Okay, if you don't know where to watch this head. Okay, watch this head.
you need to repeat once again the experimental results? No? Everybody's clear? Yes. Okay. What is the energy conversion of number 5, the fruit block? Number 18. Can you answer me? Number 18. Number 18, please remember. What is the energy conversion to? Yes. Number 20. Yes. What is the energy conversion of number 7? Sorry? Thermal energy is thought in
is when the light microscope is switched on, it converts electrical energy into light energy. So this is the demonstration and the example of the worksheet. Here, it's the division of labor. The one who are sitting near the window is student A. Can you raise up your hand? Student A. There should be 8 hands raising up. I can only see 1, 2, 3 hands. How about the other 5? The one sitting next to the window, near the door, should be student A. Student A, raise up your hands. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So you are the observer. You need to observe what in the laboratory is involving the energy conversion. You can stand up and walk around if you feel so. Student B, raise up your hand. 1. Then maybe 2 student B. 2 student B. 1. No, 2 student B only for this group, okay? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes. So you 9 are the reporter. You should be able to holding up a pen and write down your results and also your observation. Student C, raise up your hand. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So you are the grammar checker. Because we're going to write a full sentence, right? It's in English. So please help me to check if there's any grammatical mistake. Student D. Student D, raise up your hand. 1, 2, 3, 4, 5, 6, 7. How about this? 1. Who is student D? 1. Yes, student D, right? You know what you need to do? It's the organizer. Yes. So, you have 8 minutes. So, it starts now. By the way, remember, you can write it on the back of the student observer, sit down. Thank you. So I can see most of the students has already finished their part, right? Right? So now it comes to the presentation part. Can I invite one group to come on to present? Yes? Can other roommates also come up? Everyone has their task. Student A, who is the student A in group 2? You. Then you answer, what have you observed? And student B, you answer, what do you deduce? How do you deduce the energy conversion? And student C, read aloud the full sentence. Student D, summarize the whole line. So student A, please. Listen, you need to copy their findings down on the paper. What group are they? So first of all, introduce yourself. We are so they are
we are group 2, and this is also I am so he is Joe and he is Vicky.
What have you observed? Student A, what have you observed? Computer and student B. How do you deduce the energy conversion? Deduce means identify. How do you know that it is from one energy to one energy?
Because there's the computer is connected to
Socket, right? Because it has a clock and then you need to plug in, right?
and then when it plug in at the light
Yes. Student C. Student C. So copy it down. What is their observations and copy their findings down. Learn by numbers. When the electrical energy converts to light energy and heat energy, then also the electrical energy is turned into light energy and thermal energy. Summarize the whole line.
Okay, so first we just observe the computer type and the mesh. And then mesh is focuses chemical energy to light energy and thermal energy. And then the computer is focuses the electrical energy to light energy and sound energy. Then also is the electrical energy to focuses the light energy and thermal energy. Yes.
means that energy can be another one. I want another to answer me. Yes? Yes, can be converted from one form to another. And second key question. Energy conversion is everywhere. For example, can I invite number 10 to answer the question? Number 10? For example? What have just group 2 presented? Their observation is I can't hear her. Yes, thank you. So, for example, computer converts the electrical energy to light energy and thermal energy. So next lesson, we're talking about more atoms, right? We know that it's one energy converts to another energy, but is there any other energy in between? Yes. So next time we're going to talk about this, and we're have some assessment to do. One is self-assessment, and the other 3 are the homeworks that you need to take home. First one is the group work. You need to upload the findings of your team to the teams, and then every one of you need to copy the findings of others on your own paper, and also the workbook and the lesson plans. And I will send this picture to you on Teams as well, so no worries, you don't need to copy it down. So that's the end of our lesson. Goodbye, class.